Okay, good evening. This is Professor David J. De Los Reyes. Okay, the date for today is November 29, 2023, and the time is around 6:38 p.m. Okay, my topic for tonight will be a continuation of my subject matter trigonometry, and we are now on lesson number 32. Lesson number 32. This is a continuation of the long video format discussion trigonometry. Okay, let's proceed. The subject matter for tonight will be trigonometry, and we are now on lesson number 32. The title of the topic will be sine and cosine of a double angle. Normally, we are having identities in the so-called single angle. If it is angle A, it's just simply angle A. If it's angle B, it is just simply angle B. But sometimes we are solving problems that involves not just simply angle A, it twice angle A or twice angle B. That's why we must have to bring out the identities, okay, relating to these double angles. I will now give you the so-called, what you call the secret of this one, because later on, for those of you who are going up to integral calculus, you will be needing this formula here, identity here, and this identity to solve integral calculus. Because without knowing these trigonometric identities, that is a single angle in terms of a double angle, it's impossible to solve this integration problem. So to solve this integration problem, we must have to bring out the relation of a single angle in terms of a double angle. Because if we try to insist on the solution of a single angle, we could not do it. And the proper way on how to solve it, we must have to express this single angle in terms of a double angle for the solution to be the easiest one. Okay, let's proceed. We will be deriving four identities involving a double angle here in terms of a single angle. Okay, let's bring out formula number one, this one. Let's derive this one. This one here emanates from this. It emanates from the expansion of the sine of two angles, right? The two angles on the first one are not actually equal. But in here, under trigonometry lesson number 32, the angles are actually not just simply equal to each other. It is twice the original single angle. Okay. One of the formulas under the double angle is actually two angles. It should be the sine of the quantity A plus B. Two angles, right? A and B. And we have derived this one as this equal to be sine of A cosine of B plus cosine of A sine of B. If this is plus, this should be plus, okay? My code, it will be sine cosine, cosine sine, right? Sine cosine, cosine sine. If this is plus, this should be plus. So the expansion of this will be sine of A cosine of B plus cosine of A sine of B. Okay? Supposing there come a time that A is equal to B. Okay? Going back to this original identity, let's now try to substitute B to be equal to A. So this is sine of the quantity A. Then we replace B again by A, because the given condition is that at the instant that A equal to B, what will happen? So this should not be sine of the quantity A plus A again, because B is equal to A. Then this should be equal to, we could substitute B in terms of A and B in terms of A, then try to simplify. So this should be sine of A cosine of B, but B is actually A, so this will again be cosine of A, plus cosine of A, sine of B, but B is equal to A, so this will now again be equal to sine of angle A instead of angle B. Okay, so what will happen? This is cosine of A, cosine of A, sine of A, sine of A, first one, second one, so this will now be 2. Right? Similar terms. This one, cosine of A is just ahead, but the operation is multiplication. So actually, we could rewrite this one as sine of angle A, cosine of angle B, if we try to cross out this one. So sine of A, this cosine of A, cosine of A, one term, another term, so this is 2 terms on the right. Twice sine of angle A, cosine of angle A. And for the left hand side, A plus A, okay, is 2A. So sine of the quantity 2A should be equal to 2 sine of angle A, cosine of angle B. This should be identity number 1 under the so-called sign of a double angle in terms of a single angle. This is a single angle, this is a double angle. Okay, so if you are solving problems involving double angle, and it's a must that you should convert from single angle to double angle, use this one. Okay? Try to memorize this, because when you go up to the so-called study of integral calculus, you will be needing this one in the so-called solution of integration involving powers of trigonometric functions. Okay, let's try to derive cosine. We derived cosine already as a function of sum of 2 angles, right? That is a cosine of the quantity A plus B is equal to, we derived this one already. Cosine of A, cosine, cosine, sine, sine. If this is plus, this should be minus for cosine. So this is cosine of A, cosine of angle B, minus sine of angle A, sine of angle B. This was the original identity in terms of 2 angles which are not equal. Or supposing A now will be equal to B, what will happen? Try to substitute B to be equal to A back here. What will happen? Cosine of open quantity A plus B, but B is equal to A, so this will again be A closed quantity equal to. First one, it's cosine A. Next one is cosine of B, but we have said that A is equal to B, so instead of writing B, we will write it again as cosine of angle A minus sine of angle A. This is sine of angle B, but B is equal to A, so we will write this one instead of sine of B, we will write it as sine of angle A. Oh, what will happen? The left hand side will be cosine of twice A, double angle, that's why it's double angle, equal to a cosine, and a cosine will be a cosine square of A. And a sine multiplied by sine will be sine square of A. Okay? This will be the second formula needed under the so-called cosine of a double angle. That is, a cosine of twice an angle is equal to the cosine square of that angle minus the sine square of that angle. How do you prove that this one is actually correct? Think of any angle, place it here, then try to simplify the left hand side and the right hand side. What will come out should be an equality. Okay, that's the only way that we could check the validity of this one. So the second formula under the so-called cosine of a double angle is cosine of twice an angle equal to the cosine square of that angle minus the sine square of that angle. You must have to memorize this one and this one. Okay, let's try to bring out 2 added identities needed in the so-called study of integral calculus. Okay, so we mark this one and this one. From the original identity, sine square of angle A, single angle, plus cosine square of angle A is actually equal. This is actually our number 1 identity under the study of trigonometry, right? Single angle. Supposing we'll compute for cosine of square of A. Cosine square of A will be equal to 1. We transpose this to the right. This is 1 minus sine square of A, right? We'll go back to the definition of cosine of 2A, formula number 2. We'll follow this. Left hand side will be cosine of 2A. We just rewrite it, equal to. The first term on the right is cosine square of A, but cosine square of A is actually 1 minus sine square of A. It is this. Right? The next part is minus sine square of angle A. Actually, we could remove the parentheses now to expedite the solution. What will happen? Cosine of twice of A equal to, this is 1. This is a minus, this is minus, this is sine square of angle A, this is sine square of angle A, so this is 1. This is 1, this 1, so these are similar terms. So if we try to take the sum of these, it will be twice sine square of angle A, their common sign is negative. So the next thing is we try to simplify, right? We'll move this one to the left. So this will be now twice sine square of angle A equal to 1. We maintain this one. Then we will transpose this one to the right. So this will now be negative cosine of twice of angle A. And if we try to compute for sine square of angle A without the value 2, we'll try to multiply this by 1/2. See? So these two here cancel with this. So sine square of angle A now will be equal to, the total value of the right hand side should be multiplied by 1/2. So this is 1/2 times the quantity 1 minus cosine of twice A. Okay? This will be the third identity needed in the so-called study of integral calculus. That is a single angle in terms of a double angle, but this is a sine function and this is a cosine function. Okay? So in general now, sine square of angle A is equal to 1/2 times the quantity 1 minus cosine of twice A. I place here in parentheses, use an integral calculus. Later on, I will show you how we could use this one to simplify calculations under the study of integral calculus. So this will be the third formula. Single angle, double angle. Next one. We'll go back to the original identity, sine square of angle A plus cosine square of angle A is equal to 1. Instead of solving for cosine square of angle A, we'll solve for sine square of angle A. So sine square of angle A should be 1. Since we are solving for sine, cosine should go to the right. So this is minus cosine square of angle A. Then we'll try to substitute this value here to formula number 2. We'll follow this, but we replace sine square of angle A by this equivalent. So cosine of twice A should be equal to, the first one on the right is cosine square of angle A. We just rewrite it. Minus of n quantity. I put a quantity because the substitution contains two terms, right? Minus of n quantity 1 minus cosine square of angle A. And if we try to simplify, okay, we expedite a little bit. We remove this quantity now, right? So a negative 1 times a positive 1 will be a negative 1, right? And a negative times a negative, this will now be equal to plus. The sign of the cosine square will now be plus, right? If we try to take note of the right hand side, this is cosine square of angle A, this is plus cosine square of angle A. They are similar terms, so this is now twice, right? The pure constant on the right will just be simply minus 1. Solving for cosine square of angle A without the 2 here, we multiply all terms by 1/2. So these 2 here cancel with this. The left hand side now will be cosine square of angle A equal to, the right hand side will be a factor 1/2 times the quantity, the sum of these. 1 plus cosine of twice of angle A. So this should now be formula number 4. So this is now a cosine square of a single angle in terms of a cosine of a double angle. And the application of this, it is still in the so-called study of integral calculus, used in the so-called integral calculus to simplify calculation. Okay? Okay, I will show you the importance of identity number 3 and number 4. This is number 1, 2, this is 3 and 4. This 3 and 4 is actually very important in the so-called elimination of a hard solution under the study of integral calculus. So for those of you who are taking an integral, you could understand my explanation here. Supposing we are given the integral. This is simple for the integral. We are on trigonometry, don't worry guys, because I am teaching all mathematics from algebra to higher mathematics. So I could teach trigonometry and at the same time integral calculus at the same time. So to illustrate the importance of this, supposing we got the problem, the integral of sine square of x dx. We are asked to evaluate the integral of this. This is now integration. If you try to think of a formula on how to integrate a sine square function, you could not imagine any formula. So the only way we can solve this one is to eliminate this power 2 here. And to eliminate this power 2, okay, we must have to use this identity here. This is sine square of A. The angle could take any value. It could be x, it could be y, it could be b, it could be c, right? So sine square of x dx. So it seems this is similar to this, right? So the way we could solve this one is to replace this one by this. Okay? You could replace it if you could recall it, but if you could not recall it, you've got a problem. Right? So the right hand side now will be equal to sine square of x in terms of a double angle should be the integral of 1/2. I'm following this. Of the quantity 1 minus cosine of 2x. Why it is 2x? The angle here is x, the angle here is a. We could change the designation of the angle. Close quantity multiplied by the x. Okay? And if we try to expand this one, there will be two integrations. 1/2 the integral of the x. Sorry for that one. And the second one will be negative 1/2. There's still a factor negative 1/2. Okay, the integral of cosine of twice of x dx. This is now integrable because there is a formula on how to integrate the cosine of u du. Okay, you got what I mean? Because if this is a square, it's impossible for this to be integrable. But after the replacement, the second integration is just simply a plain cosine function, and there is a formula on how to take the integral of a cosine function. So actually that's the what you call this reason why we replace this sine square function by a cosine of twice function, because there is an integral for a cosine function without the second power. Okay, we verify u to be 2x, du will be 2dx, it is 6/2. And we know that the integral of a cosine is just plus sign, right? So this is 1/2, the integral of the x will just be simply x. This is minus 1/2, okay? We place it 2 inside, so we place it 1/2 outside. So this is 1/2, again multiplied by 1/2. We neutralize this 2 here inside, and we place 1/2 outside, right? So this is 1/2, and the integral of a cosine, there is a standard formula on how to take the integral of a cosine. It's simply plus sine of that angle. So the integral of this will be sine of 2x, because if this is a square, that's another thing, right? But it is just simply cosine. And there is a formula on how to take the integral of a cosine. So this should be sine of 2x plus c. Simplifying this one, algebra, right, guys? 1/2 of x, 1/2 times 1/2 is 1/4, sine of 2x plus c. So without knowing this identity, we could not solve this problem here. So it's a must that you could recall your identity uh, and bring out the relation of a single angle in terms of a double angle to simplify the integration process. For the second one, it's the same, cosine square function. Supposing we are asked to evaluate the integral of cosine square of x dx. This is with the power 2. If the power is actually 1, that will be automatic to be integrable, but the power is 2. And we could not do anything about it without replacing this single angle in terms of a double angle. And where do we get it? It's formula number 4. So this should now be 1/2. We'll copy this. We replace a by x. The angle here is a and the angle here is x. Okay, it doesn't matter. 1/2 times the quantity 1 plus cosine of 2x dx. Again, expand. 1/2 the integral of dx. This is plus, right? Plus 1/2 the integral of cosine of 2x dx. And actually this is now integrable. There is a standard formula on how to take the integral of a cosine. It is this, right? But we must have to verify the differential u. The total angle here is twice x, right? So u is 2x. Differential angle, taking the differential of both sides, it should be 2 times the differential of x, or just simply 2 dx. It is not exact. So we place 2 here, then we place 1/2 outside. Okay? 1/2 the integral of dx will just be simply 1/2 x, and a 1/2 times 1/2 is 1/4. And the integral of plus cosine is actually plus sine. Sine of 2x plus c. So the final answer will be 1/2 of x plus 1/4 sine of 2x, okay, plus c. You could check this. Because if you try to take the derivative of this, what will come out should be this one. The integral or the derivative of sine of 2x is actually plus cosine of 2x times 2. It will come out as this one, the second one, without the power 2. It's this. It's easy to verify if this is correct because if you try to differentiate this one, what will come out will be this one. Okay? And this one has been integrable because of the replacement of the cosine square function in terms of a double angle. Okay, that's it guys. That's the importance of the so-called sine and cosine function and the so-called integration process under the study of integral calculus. So without knowing this identity number 1, 2, 3, and 4, okay, you cannot proceed with integral calculus. So I am just telling you now the importance of this. When you reach integral calculus, you will be needing this, but the problem is you must have to recall it. Okay, good evening from Los Angeles, Professor David General Strait.